Let's analyze histograms and frequency tables with grouped data. Now, a frequency table is simply a way for us to organize data, least to greatest, with corresponding frequencies, where frequencies is just how many times data values appear in this group, because we are going by classes. So, for example, the frequency table below to the left represents ages at an amusement park. So we have the class that shows ages 0 to 8 with a frequency of 14. Class 9 to 17 has a frequency of 52. Class 18 to 26 with a frequency of 31. Ages 27 to 35 with a frequency of 48. And then the ages of 36 to 44 with a frequency of 26. Now we can use that to answer some questions. So what age group has the most people? So you need to recognize that most people, that means the highest frequency. And in this case, the highest frequency is 52 for the age group of 9 to 17. And what age group has the fewest people? So now we're looking for the smallest number in the frequency column, and that is 14 for the age group of 0 to 8. So we can do that just, the most and the fewest just by looking at the frequency. Now, if we look at question C, how many people are 27 or older? That is two classes together. So the 27 to 35-year-olds and the 36 to 44-year-olds. So I'm going to add those frequencies together. 48 plus 26 gives me 74. So we know that there are 74 people aged 27 or older at the amusement park. Now let's shift from a frequency table to a histogram. Now a histogram is simply a bar graph that displays continuous data. This means that the bars touch. Ooh, wrong word. The bars touch because the data is continuous. They just go on, kind of merge into each other. So the big thing here is when you think about is this data continuous? Ask yourself, can we have decimals and fractions with these? How many ounces of water can I drink? Well, I can drink 2.5 ounces of water. That's fine. So that would be continuous. But if I would say how many goals can I score in a soccer game? I can't score 2.5 goals. I can score 2. I can score 3. Cannot do. So that would be discrete. Not continuous. Okay, so let's look at this here histogram. The histogram below shows the ages of people and the frequency associated with each age. So you can see the bars touch. They share sides as they continue on. All right, so we have the endpoints are shown. So the first bar of the endpoints of -0.5 to 8.5, these are the ages of basically 0 to 8. And then we have 9 to 17. So these marks, the 8.5, 17.5, 26.5, these show the midpoint between the two bars. Let's go ahead and answer some questions. At what age group has the most people, and how many is that? So when we're looking at the most people, we're looking at the tallest bar because of the most frequency. So the first bar is at 15. Then we have 25, then 20, then 5, then 35. So obviously the bar of 35, that's the how many, and that represents 35.5 is the low end. So that means the age starts at 36 because it's the bar to the right and goes to 44.5. So that stops at 44. So the age group would be 36 to 44. What age group has the fewest? And how many is that? Well, let's go back to our histogram. The shortest bar was 5. So that's the how many. And which bar is that? Well, it's the 26.5 to 35.5. So that means it's 27 to 35. Because once again, those are the midpoints between two groups.